All right, welcome back. So in this video, we're going to start by building our KNN. So we started with preparing our data and then getting it ready for model building. All right, so there are a lot of other things that you can do, like maybe some visualizations of the various attributes in here. Right, you can also do that. Right, checking for maybe some outliers and some missing values. I mean, you can check. I mean, you can do a lot of stuff in there. All right, so there are other exploratory data analysis that you can also do in there. Now, what I'm going to do over here, right? I mean, what we did, over here is quite enough for this particular understanding, right? It's quite enough, right, for this particular understanding. So we can proceed with that, right? And if you want to do a further exploratory data analysis, you can also do that. Okay, just like we did in the logistic and the linear regression class. All right, so now what I'm going to do is that I'm going to use this library which is present in model selection, right? And sklen.model selection. We have this train test split which I'm going to use over here to split my data, right? To split my data. So don't forget that we have our scaled df, right? After we scaled our data, we store everything. We converted it back to a data frame and then we store everything in what's called scale_df. Okay, so that's what I'm actually going to use over here. Then I'll pass in my y to which is going to be my target. All right, which is going to be my target. Then I have my test size. Remember that over here test size equals 0.3, which means that I'm using 30% for testing and then I'm using 70% for training. All right, then I'm setting my random states, right? I'm setting my random state equals 1 so that I'll be getting the same random variables over and over again as I run this notebook. Okay, so as I always say, right, the part of the training the part of the scaled that I'll be used for training, I store it in a variable called strain, and the part of the part of the scaled for testing, I'll store it in a variable called test. Okay, and then the part of the y that I'll use for training, I'll store it in what is called the y train, right? I'll store it in what is called the y train, and the part of the y that I will use for testing, I will store it in what is called the y-test. So basically, that is what we are doing over here. Now, when it comes to this part, right, this is when we start with our K-Nearest classifier. Okay, remember that's what we're doing over here, K-Nearest classifier, right? K-Nearest Neighbor, right? So we have what is called the K-Nearest classifier, okay, which is present in sklen.neighbors, right? So from sklen.neighbors, we can import the K-Nearest classifier, which we are going to use for this classification, right? Because this is a classification problem. We have either a cell is going to be benign or is going to be malignant. Okay, so it's a classification problem, right? And that's what we are going to use. So we're going to need the K-Nearest classifier in this particular example. Okay, so if it's a regression problem, then we will need a K-Nearest regressor to do that, right? In this case, it's a classification problem, so we need the K-Nearest classifier. So initially, as I said, we can use the K-Nearest for both classification problem and then for a regression problem. All right, so since this is a classification problem, we are using the K-Nearest classifier. But if it's a regression problem, then we're going to use the K-Nearest regressor. Okay, but in this case, classification problem, we are using K-Nearest classifier. So get to note that. All right, so what we do as we did in the other classes, in the logistic and in the linear regression, what we do normally is to initialize our algorithm, right? So over here I initialize it, right? So this is just let me open this one so that you actually get to see what okay, so this is basically the same thing over here. So I'm initializing it, then I'll store it in a variable called KNN. Okay, and then the neighbors, right? The neighbors here, I'm setting the neighbors randomly to 5, right? Later on, we'll talk about how to choose this neighbor. So this neighbors is what we refer to as the K, right? This is the K that we've been talking about earlier on, right? This is the K, right? So in this case, the K here is 5. Remember that I told you the K represents the neighbors, right? That is the number of neighbors that you have. Okay, that's why n neighbors, which is the number of neighbors, right? It equals 5. So this one I'm choosing it randomly, but later on I'll show you how you can, the best way to choose this K. Okay, and then the weight, I'm saying that the weight should be distance, right? What that means is that
it's 10 o'clock.
What that means is that if we use the weight to be distance, right? What I'm saying is that the distance, right? The distance between various points, right, should be considered, should be given a priority, right? So the closer the neighbors are, right, the more the more important they are, right? The more important they are. If you use the uniform, right, it means that we are going to give yeah, an equal weight to each of the points, right? We are going to give an equal weight to each of the points. So if you see this part, right, if you see what we're dealing with over here, right, what I'm saying is that if I check the distance, right, if I check the distance, right, and the distance between this one, right, let's say this one is 12, right, and then let's say this one is also maybe 12.5, something like that, right? This one will be say 12.5, and then maybe this one is 3, right, something like that. So it means that 3 is closer to this point, so this one should be given more importance, right? So the distance should be considered. Okay, but if I use uniform, it means that they are all going to be considered as equal, right? They are all going to be considered as important, and then it's not going to be based on the distance, right? It's not going to be based on the distance as if you specify, specifically that the distance should be, the distance between the points should be importance should be placed on the distance between the points. All right. So basically, that is what the distance will actually do, right? So let's go back to what we were doing over here. All right. So let's see the next step that we can do here now. We have initialized our data. So the next thing that we can actually do is to fit our data. That is, to fit our model. Okay. So what we can do here after initializing our model, we store everything in a variable called KNN, right? So KNN is going to be our model, right? So we are making that to learn from this, right? So let me just open this output. Okay. Now we are making this, right? We are making this KNN variable, which contains our K-Nearest Classifier, right? It contains our K-Nearest Classifier to learn from this training data, right? To learn from this training data. Okay. So we have S train and a Y train. So this actually represent my 70% that I want to use for training. Okay. So, and the fits, you can think of the fit here as learn, right? So our model is going to learn from the training data, right? From the training data. All right. So after we do that, right? After we do that, the next thing that we can, so if you run it, you will get this output. Okay. The next thing that we can do is to make some predictions. Right now, it has learned from this. The next thing that we want is to actually use our model which has learned, right? To use our model which has learned to make some predictions. So just think about this one as let me actually make this and then open this output. Okay. Now so you can just think about this, right, as this data, right, as existing features that we have, right, for the cell, right, for the cells. That some of the cells in this training data, right, some of the cells were B, right, that is for benign. Some of those cells were malignant. Okay. So we already know these. So we feed these features into our model, right? And then our model learns from that. All right. Now think about this S-test as new data, or new cells that are coming in, right? So new cells that are coming in. So with this S-test, are we able to predict whether that cell, right? So this is going to be several cells. Okay. It could be 1, it could be 2, it could be 3, it could be more than thousands of cells. Okay. So can we base on these cells, right, which are having same features as we were using earlier on, right? So can we base on these new cells and then predict whether that cell is going to be benign or is going to be malignant? Okay. So if we feed that one to our algorithm, or to our model, right? If we feed that one to our model and then use the predict function, you can see that we store everything in what is called KNN underscore predict, right? So if we run the KNN underscore predict, we see that we are making some predictions over here, right? We're predicting some cells to be malignant and we're predicting some to be benign. Okay, so we see that our model is working perfectly, right? It's able to, based on old data to make predictions of a new data. Okay, so based on the old cells that we're having, right? We have learned from the old cells and we're able to predict, new cells to be either malignant or benign. Okay, so that is basically what is happening here. That is what we actually want to do. So the next thing that we can do is to check the score and then see how well it is actually doing. Okay, so we're going to check that score on the testing data. All right, so here is where, let me open this one, right? So here is where the 30%, right, that we want to use for testing also comes in, right? So we use the 30% to check the score, right, to check the score. Remember that we use the S test, which is part of the 30%, to make the predictions over here. Okay, so we're going to check the score on that. So now if we do that, we have 96%, which is quite good, very good, right? We have 96% over here, which is doing very good. All right, so our model is working and it's good over here. All right, so the next thing that we can do is to use the confusion matrix. If you remember from the previous class, we actually talked about this confusion matrix. So if you build the algorithm, you want to know how many B's you predicted as B and how many B's you were wrongly predicted, right? And then how many M's were able to predict as M and how many of them were wrongly predicted. You can actually use the confusion matrix to actually visualize that. So let me show you the output over here so that we can actually work alongside it. Now, from sklearn, right, I'm going to import what is called the matrix. Okay, from sklearn, I'm going to import what is called the matrix. So I'm just printing the title over here, just print confusion matrix, and that is what you can see over here. Okay, now from in matrix, right, I'm going to use what is called the confusion matrix, right, and I'm passing in my y test, which contains my test data, and I'm passing in my knn underscore predict, which contains my predictions, right. Remember that after we built the algorithm, we made some predictions and we stored everything in what is called knn underscore predict. So if I should show you up here, you can see over here, right, we stored, when we made the prediction, we stored everything in a variable called knn underscore predict. Okay, so that is basically what is here, right, knn underscore predict. And then my labels, we have either M, right, we have either M or B, right, we have either M or B, that is either malignant or benign. Okay, that is basically what we have. Now, after that is done, right, after that is done, I store everything in a variable called CM, that is just confusion matrix. Okay, you can use any variable name that you want. Okay, now after that is done, I'm going to convert everything into a data frame. So I store everything in I brought everything here, right, so that I'll be able to convert it into a data frame. So I have my CM here and I'm setting the index. So in the index, you can see I have M and then B over here, right? That's what you can actually see over here. That is M and B. And then the column, right, I want predicted M and then predicted B. So that's what you can actually see, predicted M and then predicted B. Okay, that's what you can actually see. Okay, so after that, right, I convert everything into a data frame, right? I convert everything into a data frame. And then I store everything in a variable called df underscore cm. That is data frame of the confusion matrix. Okay, so then if that is done, what I'm going to do over here is to use the heat map, right? Is to use the heat map. So I'm using sns.heatmap, right? And then I'm passing in this data frame that I did, which is df underscore cm, right? And I'm setting the annotate, which equals true, right? Which is nothing but the numbers that you can see over here, right? Annotate equals true, right? So I'm using the heat map to do that, which is present in Seaborn. Then I'm using plt.show so that I'll be able to see everything. Okay, so basically that is the code and that is the output. So now what we can do is to actually take a look at this output, right? Let's now take a look at this output. Now this is the original. This is what I wanted to predict, and this is what I predicted, right? This is my prediction. This is the original. Now if you see the M, right, if you see the M, we have 53 and then 4. So we have actually 57, right? 57 of the M, right? So at the M were actually 57, and then the B, right, the B were 110 plus 2, right, which is 112, right, 112. Okay, that's what we actually have over here. So this 11e plus 02, right, is nothing but more like 11 multiplied by 10 exponent 2, right? So you're going to get 110, right, 110, and then I have 2 over here, so I added the 2 to it, right? That's why I'm having 112 over here. Okay, that's what I'm having over here. So I have 57 malignant, then I have 112. This is 2, so don't confuse it with 7. I have 112 benign. Okay, now out of the 57 malignant, right, I was able to predict, out of the 57 malignant, I was able to predict 53 of them correctly as malignant, right? So the M's, right, if you see the M's and you trace it to the one that I so this is my predicted M, this is the original M, so where they meet is the one I predicted correctly, right? So this is M, and then you can see that we have this one. Let me change this. Okay, you can see that we have this 4 over here, right? And then I have predicted B. Now, this is supposed to be, these 4 were supposed to be predicted as M, right? But I wrongly predicted them as B, right? That's why they meet over here. I wrongly predicted them as B, so you can consider this as wrong prediction. Whilst while this one, right? This one here is a right prediction. Okay. Then if you consider this part, right? If you consider this part, the B, right? The B. Let me actually use this. If you consider the B, right, which is benign, right? If you see where they meet, the B and my predicted B, they all meet here. So 110 of them, 110 of the B's, I was able to predict them as B. Okay, that's why the B and the B meet here, right? So 110 of them, I was able to predict them as B. However, I wrongly predicted 2 of them, right? I wrongly predicted 2 of them, right, as M. 2 of the B's which were supposed to be predicted as B, I wrongly predicted them as M. So you can consider this one too as wrong prediction. So if you trace this part, you can see that this is wrong predictions, right? And if you trace this part, you can see that this is actually a right prediction. Okay, so you can see that mostly I was able to predict some of them correctly and then a few of them wrongly, right? And then that's why our algorithm is actually doing well. If you consider the accuracy over here, 96 is very good. All right, so very few of them that I was able to wrongly predict it. Right, very few of them. If you consider 110 of them were right, only 2 of them were wrongly predicted. All right, so this one is actually doing very good. This one is actually doing very, very good. All right, so now that is how we actually build our algorithm, and that is how our algorithm is actually doing. So in the next video, we're actually going to consider how we're going to choose our K. Okay, so I'll see you in the next video how we're going to choose the K. And I mean, if you remember this K, I chose this K randomly, right? The number of neighbors over here, I chose it randomly. So in the next video, we're going to consider how we will choose this K. All right, so see you in the next video.